Isn't these two equations the same? Well, in fact, no, because for the first one, x is a real number, and for the second one, z is a complex number. And let me show you the difference, starting with this one first. And we'll use the definition of the absolute value. First, for the absolute value of x, let's rewrite that as the absolute value of x minus 0. This is still going to give us x. And this is equal to 5. And the reason we want to do this is because now we can look at this as the distance for the absolute value, the distance between this and that. So let me write that down for you guys. We are trying to figure out the distance between what x value and 0 is 5. And the best way to do this is actually just draw a number line like this. So this is just a one-dimensional situation, and let's say 0 is right here. Now I want to go from 0 away to 5 units. I can go to the right 5 units, right? So done. This tells us this distance here is 5. I will just say d is equal to 5. Great. But could we have gone the other way? Sure thing. This is like you starting at your house and then you are running to this direction 5 miles. Distance is 5. But you could also have gone the other way, and in that case you end up with negative 5 on the x-axis. But the distance that you travel is still equal to 5. So in fact, we end up with two possibilities, right? And those are the answers for x. And I will write this down for you guys. I will write it down in the set builder notation because for this purpose. So the answer for this is x belong to the real numbers such that x is equal to 5 or x equal to negative 5. Or you could have just put the set notation and then just put 5 and negative 5. I think that's totally fine too. Alright, for the second one, here is the biggest difference between the real case and the complex case. When we are going to the complex case, right, we will go to the complex plane. What I mean by that is, here, this axis is the real axis, here is the imaginary axis. When we have a z in the complex plane, let's say it's somewhere here, we can write z as a complex number in the standard form, which is a plus bi. The distance from here to here is a, the distance from here to here is b. The rest is the same though. The distance between z and 0, let me write that down right here first. Absolute value z minus 0, we want this to be equal to 5. This is still telling us we want the distance between, and we have to figure out what complex number z and 0 will give us 5. But in this case, we are in the complex plane. So let's have a look. Once again, 0 is at the origin. And now, okay, I want to go away from 0 to here, let's say 5 units. So that's 5. Great. And I can also go to the left 5 units and I will end up with negative 5. Okay. But could I also have gone up 5 times? Yes, I can also go here 5 times, and in this case it will be 5i. Alright, it will be 5i technically. This number right here is 5i, and here I can also have gone down 5 times. But could I also have gone like this 5 units? Yes. Could I have gone the other direction? Yes. In fact, we'll just have a circle. It's like you run around a circle. The circle is the set of all points equal distance from the center. So the radius of this circle is just 5. Okay? And take a look. From here to here, let's say this is just a complex number in the standard form, a plus bi. So from here to here is a, from here to here is b, and this right here is the distance, and we want it to be 5. By Pythagorean theorem, because this is the right triangle, we know a squared plus b b squared has to be equal to 5 squared. So now, we are going to write a solution for this. We are going to write the set builder notation. Here we have infinitely many solutions. I will write z equals a plus bi, and then you can indicate that that's just a complex number, such that the condition is we want a squared plus b squared is equal to, let's just work out the 5 squared, which is 25. So, any point on this circle is a solution to this right here.